Every time you look at your phone to unlock it, dictate a text message, or watch it finish your sentence, you are using artificial intelligence. It is easy to picture this technology as a conscious, thinking entity inside your device. In reality, it is a hyper-fast system that simply recognizes patterns to anticipate exactly what you need next. Early mobile phones operated entirely on rigid, pre-programmed rules. If you pressed a specific button, it did a specific thing. Modern phones operate more like a digital brain. They take in continuous data from your habits and surroundings, and they learn from it. Moving away from strict programming and toward this kind of learned pattern prediction turns a regular piece of glass and metal into an automated, highly personalized assistant. The AI pipeline understands math, not text or voice. Tokenization chops words into pieces, swapping them for numbers. Pattern recognition maps relationships, assigning mathematical weight to find context. Finally, it predicts the most likely next word, like rolling weighted dice. When your device feels like it perfectly understands your intent, it is actually just completing a highly efficient math problem to guess your next move. To capture a photo, your phone combines its physical glass lens with a system called computational photography, essentially building the final image out of data. If you snap a picture in the dark, the camera captures multiple photos at different brightness levels in a fraction of a second. The system then uses pattern recognition to compare those images, merge the best individual pixels together, and strip out the dark, grainy noise. The system also recognizes what it is looking at. If it spots a human face in the frame, it instantly adjusts the math to highlight natural skin tones and balance the lighting. The exact same logic applies when you talk to your voice assistant. The microphone takes your messy human audio, chops it into tiny sound units, converts those units into text, and maps out the exact parameters of your request. Whether it is processing light data for a sunset photo or sound wave data to set a timer, the phone executes the exact same mathematical process to deliver the right result. Processing all of this data takes a massive amount of computing power. This raises a mechanical question. How does a thin device with a small battery handle that kind of weight? This diagram shows a specialized section of your phone's internal hardware, a dedicated pattern solver called the NPU. It acts like a high-speed calculator built specifically to run the math for AI tasks without draining your battery. Running these tasks on the local NPU has major benefits. It is lightning fast, it works completely offline, and keeps biometric data private, because facial scans and voice prints never leave the phone. However, complex tasks like drafting an email or answering complicated research questions exceed the limits of that small local chip. For those heavy requests, your phone connects to the internet and sends the data to massive, powerful cloud server farms for processing. Your phone is constantly performing this balancing act, routing simple, private tasks to the secure NPU and handing the heavy computational lifting off to the cloud. Having this system built right into your pocket saves you time, keeps your personal data secure, and elevates the quality of your photos and videos without requiring technical skill on your part. As the memory and NPU chips inside these devices grow more powerful, we're moving toward a point where increasingly complex processing can live entirely on the phone itself. This power makes instantaneous language translation possible, letting you converse in another language as audio waves turn to text right on the screen. Your smartphone is now a proactive learning assistant, constantly finding ways to support you through the intelligence in your pocket.